Thanks everybody for tuning in. Another episode of the Construction Dirt Podcast. Cam Roy, joined by my co-host, Mr. Jeff Knobloch. Today's episode, as always, sponsored by the JK Worldwide group of companies living the dream out here in Delta, BC. Today, Jeff, maybe you should introduce our guest today.
We have a guest.
today. Special guest today.
Yeah. We have Dylan James with us here today.
DJ.
Thanks for having me.
Yeah, and I think maybe we start off, Dylan, why don't you tell us a little bit about who you are, what you do, and if you want to do some fun connections of how you know us, we can leave that for later.
The pop bottles.
Yeah, no, I mean, I can go as far back as you want here, but briefly, my name is Dylan James. I'm with HJB Engineering in Langley, BC. We're a new firm, started in January here.
Right on.
Branched off of an existing company. There's 7 of us now, so it's a new venture, new exciting.
Do you have an office?
We do have an office.
You have an office. Where is your office?
Langley, 84th and 200th.
Nice.
Oh, fun.
So those that aren't totally aware of the type of engineering that you guys do, what's your specialty?
So my personal specialty is tilt-up construction and metal buildings, whether it be conventional steel or pre-engineered metal buildings, is what I focus on. But we do a lot of 6-story wood frame freezers and all sorts of stuff.
Sweet. You've always been known to do some fun stuff. And I don't think you've ever said no to like, hey, look at this or hey, look at that. But focus obviously on pre-engine tilt-up stuff and whatever else comes your way.
Yeah, no, I like the hard problems. I go down a lot of rabbit holes on all sorts of things. Like we just did 220 panels in Mission, BC using a new technology, structurally composite panels.
Sweet.
Yeah.
You always love the complex stuff though. Like I always feel like you're always kind of working on something. You're always excited to talk about it. And I mean, I'm always excited to hear about it too. So that's always a fun one.
I remember running into you at the airport, or we were flying back from somewhere, and then you were going, and I thought I knew BC pretty well. And then you told me this town you're going to, and I was like, where is that? And you're like, oh, it's Northeast BC. So what were you doing up there? How did that play into what you do?
Well, got a project going on right now up at the Lador Dam for BC Hydro, and it has some of the most stringent seismic specifications that I've ever seen. It's about 3 times higher than what we'd have here in the Lower Mainland.
Which is already pretty high for those.
Which is already
not in the Lower
Mainland.
Mainland.
Yeah. But the project itself was turned down by every pre-engineered metal building manufacturer out there because of the stringent specifications. So one of our clients who work closely with came to us and said, would you be willing to give it a shot? And it was a problem that needed solving. So,
yeah. You got DJ on the K's. Right on.
Yeah. So we're just finishing that up now. I think the 4th building will be starting soon, which is the 4th and last there.
Sorry, this is where we need the video podcast, because I remember you showing me some pictures of some of the structures up there for that. And
pretty crazy.
I'm a contractor, not an engineer, and I was blown away with the size. Like Greg used to say, you can launch a spaceship off the structure because of the Or if there's a world's coming to an end, I want to be hanging out underneath that one because it's gonna be there forever
for sure.
Yeah, I mean, like those buildings were designed for. I mean, it started out at 2 times the force of gravity sideways, and some of the detailing requirements required up to 9 times the force of gravity on it.
That's crazy. Eh?
Yeah,
lots of concrete
there or something.
Yeah. I mean, Jeff was mentioning you get to go to some pretty remote, random places once in a while to check on some of the stuff, or is that the only one? Yeah,
no, we do a lot of work on like pre-engineered metal buildings all over BC and Canada for that matter. And we've done a lot in Fort McMurray and Alberta. I'm looking at a couple right now in the Yukon.
There you go.
Yeah, it gets us around. I mean, it lets us see different engineering styles, different styles, different types of buildings all over Canada. So it's really cool.
That's sweet. Your personal story though, like coming from, I want to say like in the field ironworker.
Yeah. Yeah.
Are we allowed to talk about that?
Yeah, we can go all the way back. So one of my first jobs was working for my parents picking up dead chickens.
No way.
So for Sunrise Poultry, we managed a chicken farm, and that was my job when I was 6 or 7, was feed the chickens and pick up the dead ones. Yeah. And then that sort of migrated. We got away from sort of the chicken business and went to a more hobby farm. And my job there was picking up rocks in the summer.
Oh, cool.
From the field.
Yeah.
Yeah.
There you go.
That was good. And then my dad started up a steel company doing miscellaneous metals. And that's sort of where I got into The welding side, he'd shut it down for the day. I'd sneak in and teach myself how to weld. Steal some
360
rod
here,
and burn some rod. And
rock and roll.
I remember the CWB testers came out to certify some of the guys. And I go to my dad. I was like, I want to try and do the test. He's like, you don't know how to weld. I was like, I do. So
I was burning the midnight oil.
yeah. So he said, try and do the flat. And it was good enough that they sent it away. And I wound up getting my flat certification with CWB when I was 13.
No way.
Yeah.
Really?
Yeah.
Wow.
No age limit back then, or I don't even know if there is now, but
I guess
if you tried. Yeah. Next summer job was welding, essentially. By that time, my dad's steel business had grown into the point where we were doing structural steel for tilt-up buildings. So evenings, or I wouldn't say evenings, but I'd say weekends and March break and summers and all that was spent welding EM5s and perimeter angle on tilt-up buildings. So I did that for 2 summers, working for my dad's company. And then I decided to branch out and get away from the dad's company. I worked for another local company out here, ISM. So I worked for them for my grade 11, 12 summer. And then when I graduated high school, I worked for them for about 8 months. And then it was about time that I really needed to branch out. Need to do something else because you can only weld so many EM5s before he's like, okay, I need some variety in my life. So
for sure.
We had a family friend that did pre-engineered metal buildings. And I think I broke up with my girlfriend at the time and I was just like, I needed to get out. So I talked with him and I was on a plane 3 days later, I think it was.
Yeah.
I had to get my welding ticket recertified, which got done right away. And then I was on a plane to Fort McMurray to put up a big steel building in Curl Lake. Big river water intake building for Imperial Oil up there, I think it was. So I worked with the pre-eng company for, I want to say 2-3 years.
Yeah.
And then I think it was my 3rd year, I was putting up a steel building in like minus 50 weather. And I was not having it. So I was like, there's got to be something else, something bigger here. So I remember sitting down with my grandfather and having this discussion. And he said, I think you'd be good in engineering. It's like, go back to school.
Yeah.
Like at that point, I was mid-20s, and the thought of going back to school hadn't even occurred to me. But I started looking into it, and it sort of pulled together everything that I'd grown up doing, but being on the other side of it, learning the why to the how. That if you know what I mean.
Yeah.
So it kind of fit me really well, and I looked at my high school grades and they were terrible. I was like, this isn't going to happen. But I started pushing towards it. I think I went back and I did a couple summers of high school upgrading classes.
Yeah.
And that got me into a technology entry program at BCIT, which was sort of like the step before engineering school. So I did that for 6 months. And after that, I got the call that I was accepted into engineering school, and
sweet.
The rest was history.
There you go.
So where did you do your schooling?
I did my schooling at BCIT.
Yeah.
The whole complete part. And then after my first 2 years of school, you graduate with your diploma, and it's time to find an engineering job.
Yeah.
So I reached out to a couple of friends, but I ended up speaking with Curtis Gray.
Interesting. Yeah.
And sort of did a co-op with him. This was before engineering when I was looking around. And he sort of introduced me to drafting. This would have been at the old, I think, Cron engineering office way back when. I used that connection to sort of get a conversation with Doug Birch. Just speaking with him, we sort of agreed to go in for an interview, and I sat down with him and we started talking, and we started putting 2 and 2 together and realized that he was the engineer for that pre-engineered metal building up in Curl Lake, Alberta.
No way that you worked on.
And he was also, their Cron Engineering was also the structural engineer for a lot of the tilt-up buildings that I had done with ISM and my dad's company. And we started finding all these links from my past, and it just felt like it was the job that was going to fit me. So I spent my first summer break with him. Ended up staying for a whole year and a half, took a year off school. And that drove me back to go complete my degree my last 2 years. And I've been with Doug since. Worked with him for 8 years. And it finally got to the point where it was time to go out on our own. And me, him, and Michael Halliday just started up our own company January 1st of this year.
Yeah.
So
well, that's awesome.
That's the long story.
No, so I'm curious, like when we have, I say the kids out of school come in and start working here, and there's certain tasks they do, and they can only go so far. I can't picture how that works in an engineer's office. So what were some of the first things you were doing as a structural engineer for Dave?
Oh, I remember the very first thing that Doug had me look at was masonry veneer seismic loads. He's like, the codes have just updated. We've got this calculation that we've got on file, and it needs to be rechecked to the current code. So I was looking at the seismic load on masonry veneer. And the one thing they don't teach you in school, oddly enough, is seismic loading. So that was a fun task. Yeah,
even in BC.
Even in BC.
Wow.
Yeah. No,
which I mean, we're not talking to someone that's very old either. So I was like, you should just Google it. No.
Yeah. No, I mean, seismic loading, it's no different than any other static load.
Yeah.
Right. And that's how we sort of treat it, is we take a complicated problem and turn it into a simple problem. So we have a method called the equivalent static force method, where we take a dynamic load like shaking earthquakes and basically use equations to turn that into a horizontal static load and design from there.
Yeah.
And then all of our equations sort of go off there.
Yeah.
That's the easy way to do seismic.
Is it, I'll use the term cut and paste now. So when you see a tilt building and it's in that municipality that you've done a million tilt buildings for, I mean, I know the answer is kind of a tricky answer there because no two buildings are ever the same.
That's the thing. Yeah. I mean, how many boxes do we know that are true 4 walls, no windows, no doors?
Yeah.
Right. And there's always a complicated problem on a building. I mean, the complication right now is tall buildings. Once you start getting over a certain limit, then all of our equivalent static load methods kind of go out the window. We're not allowed to use them.
So is it you could build anything as long as you have the dollars to spend, or are there certain things that you just can't build?
There's definitely hard limits. I mean, even from a code perspective, depending on what material you're using, the code will say you can only go so high in a given seismic zone. Okay. And here in BC, we're in the highest seismic zone, so it becomes very restrictive. Yeah. So I think at 62 feet tall, a tilt building, you have to detail it completely different, and the codes haven't quite caught up on the tilt.
Is that why we have a 58-foot 11 in Surrey that we built?
That's exactly what.
61-foot 11, right?
Yeah.
Spoiler alert.
Yeah. Well, and I know that whole site classification as well, and I don't think a lot of people appreciate that same building. You could build a certain site in an area where the soil conditions aren't the same. You're not building the same building or at the same cost.
Totally. Yeah. I mean, site class C is a dream where it's just firm soil, no problems, call it a day. But you can get all the way to site class E and F, where you're dealing with liquefiable soils. So that means in an earthquake, the soil essentially turns to liquid. And you got all sorts of code clauses that require you to connect all your footings together and make sure it all moves as one piece. And all sorts of
I always used to love that when I was on site, like even, as a site super back in the day, looking at like just the structural design between different buildings and just like, why is there Z bars on this one coming out of the footing, and why isn't there on this one? And
must be the engineer.
Why is this? What? Yeah. I mean, I'd ask though. I'd full on I'd be like, hey, what's going on with this? And why is this embed so massive? And honestly, a lot of the times it was soil classifications.
The first question we ask is, do you have a geotechnical report?
Yeah.
And can I see it?
Well, it's pretty flat. It's a flat site. You sound
like the pre-con team. You sound like the pre-con team.
Right?
The structural engineer wants to know if
there'll be minimal site prep needed on this.
Minimal,
don't worry.
Minimal, guys. Don't worry about
it. Every client says, I just bought this, and no. They said it's good.
Yeah. And the next question or the next answer you hear is, how many piles do you want to put in?
Yeah. If you have a soils report, it's like, oh, here's our environmental report. No, like actual drill tests where you can see what's underground.
Yeah. What's their bearing capacity? I mean, the amount of variables though, like that's just one. But I mean, like the amount of variables that you guys run into, like you say, of, height of panel, specifically tilt up stuff. But I mean, you could broaden the horizons on it. But I mean, like how much does that come into play? Like obviously quite a bit, I'm assuming. Like windows, oh man, this guy wants clear glazing all the way across. And you're like, oh God.
Design elements that add snow loads.
Yeah.
You might not think of.
Yeah. biggest challenge right now is we're pushing up against what the code can handle in terms of design. The seismic loads have been pushed so high that we max out the capacity of our seismic force resisting system in almost every building. Like that's the first thing that we're looking at.
Yeah.
And I mean, wind loads don't even matter at that point. So we're getting to problems where the tilt-up panel physically doesn't work anymore. And that 62-foot tall limit, to push above that, we have to introduce more ductility into the system where we have to sort of dampen out the seismic load.
Mm-hmm.
The codes have tried to get there. They've laid out a roadmap on and tell you how to do it, but it's not fully developed. So it's almost like a trap. You like it'll tell you can do it, but when you try and do it, you can't.
It's not going to work.
Yeah. So, I mean, for that specific reason, I've started up a local BC engineering committee where we pull in all the local engineers focusing on tilt up and try and solve these bigger problems, or at least get a roadmap on how to solve these problems. How do we push up against these limits? In the latest code change, it stipulated that any high importance or post-disaster building for whatever purpose needs to have a certain level of ductility, and is a huge problem in the tilt-up market because we can't do it. The roadmap isn't there. So that immediately eliminates us from our number one, or I would say number two market of like residential schools and police departments, all of that. Yeah. All of that is no longer possible in tilt just because of a code change.
Interesting.
And
sorry, but for those that don't know, what does post-disaster, what's that definition? Like what would someone expect? So there's a disaster of some sort that building's designed to withhold or withstand.
What are the specs behind that actual statement?
Like you show up the day after the disaster, what should you expect to see?
What kind of disaster?
So this is going to be, I'm going to get the exact definition wrong. However, high importance, you're increasing your loads and your requirements enough to survive the worst of the worst earthquake and still be somewhat functional.
Okay.
Post-disaster is this building needs to be operational after an earthquake. So you're thinking things like hospitals, right? Or
data centers, some of the data centers. But
and this can either be code dictated or owner dictated, right? So the owner can come to us and say, hey, we need a building that's going to be up and running after an earthquake. What do we need to do? And we'll put it into that high importance or post-disaster category. But what it does, it increases all the loads by a factor of, say, 30 to 50%. But it will also say that you need to have enough ductility in your system to both dampen out the seismic loads.
Yeah.
Right?
What about a regular building? So a school or something that gets seismically upgraded, or a building that is now designed to the new seismic code.
Yep.
So is that similar? Like at the end?
No. So what it is every year the code gets updated. And in those updates, especially in BC, they've been pushing the seismic load up and up and up and up. And I believe in 2004 was when it really started to change. I think back then we were 13, 14% gravity sideways. If for every pound down, we've got 0.13 pounds sideways. Now in the current market, at least unreduced, we're dealing with seismic loads of 1G. So it's 100% of the load sideways. Right now, this project that I was talking to you earlier about on the island, that was 1.68 G. But that's before sort of its amplifications and reductions. So you've got the earthquake.
Yeah.
You've got it, say it's 1G. 1G earthquake, it's throwing your building sideways at 1G. You put certain elements in the building that are designed to fail in a controlled way to dampen out that sort of shaking. And that's your ductility factor, and that lets you drop your design seismic load down. So 1G sideways, you've got a ductility factor of 2. Now you're designing to 50% gravity. And the better your system, or the more controlled that failure, the more controlled that damping in your building, the ductility factor, the more you can reduce that load that you designed to. So you've got your elements that are failing in a controlled way, and the rest of the building can be designed for a much lower load.
So then that is more the life safety side. So the building might not be repairable, but the people inside or the things inside will be able to safely exit or be safe within. That's the idea of the seismic code.
Exactly. Yeah. So, I mean, let's say you're not designing for any ductility in your building. Ductility factor 1. seismic load 1G. If you're standing on that second floor, you're going to get thrown pretty hard sideways, right? Now, if you've got elements in the building that are designed to fail in a controlled way and dampen out that force, maybe you only feel half that seismic load because it's starting to fail and dampen out that energy from the earthquake, right? So you won't feel as big of a force on yourself. Or the building won't see as a whole. The building as a whole won't see that big.
I appreciate that explanation. I have friends that are like, why are we seismically big if the buildings are going to fall down anyways? I was like, well, they're not going to fall down. They're just designed to make sure you stay safe or minimize the chances of, I guess.
That ductility thing sounds fun though.
Yeah, well, it's a really tough conversation to have with an owner of a building because the amount of work that it puts on the engineer is significant, right? We can design for a really high seismic load really easily, but if you want to detail into that high ductility factor and dampen out your seismic force and have controlled failure only on your brace and the rest of the building is protected, I mean that it starts at doubling the amount of work and it goes from there, right? Because we have to dictate a couple points in the building where we're concentrating all of the failure. Yeah, right. We've got buckling restrained braces or specially detailed shear walls or moment frames that are sort of coped out to fail in one spot. Yeah. So that after the earthquake, you come in and those are what you're fixing rather than the entire building. Out here, we're designing for a big earthquake that may never happen. It's a hard sell to certain developers.
For sure.
Yeah.
It's an interesting problem.
Totally. And then, I mean, ever since a kid, the big one was supposed to happen. And then over the years, Ram's done some seismic upgrade to schools, which I think is important to, the 80-year-old building that probably won't stand up very well. Yes, it should get upgraded, but it's tough because we say to clients, well, why do I care about the seismic code? I was like, well, you should care because of those reasons, but also you don't have a choice. Like you have to meet this certain standard. And unfortunately, as the code changes, the cost of the buildings go up.
Yeah. And I think the important thing to know about engineering is it's designing for what we know today, right? We don't know everything. There's been reports just as of a couple of weeks ago where they just found a new tear in the Juan de Fuca fault off our coast. And that's going to have an impact on seismic loads. Like they're constantly learning new information and adjusting the seismic loads. Sometimes they go up, sometimes they go down, but there has been that general trend up.
Yeah. We're not trying to fearmonger here either.
No.
Like we're talking shop here.
Talking realistic codes and requirements that buildings need to get built to. I mean, that's the reason why we have some seismic pads that are 500 meters of concrete in them.
Totally. Yeah, totally.
And 12-foot long dewey decks.
And that ties, I guess, maybe even more. Like Cam and I talk when we go to the TCA events or the Tilt-Up Association events. And I always go back just the fiber mesh in the outside of our panels, and other places in the continent can get away with certain things that we can't. And there's always that, why don't you just do things like we do it here? And we're like, well, we have a seismic zone. Well, we don't even have seismic zone in the Midwest or whatever region that's
Southeast.
But then you go, well, we got hurricanes we got to deal with. BC doesn't have hurricanes. So every zone or region has their challenges, which I think mostly end up on your plate. Or not your plate, but the structural components of the building are typically the ones that have to deal with all of those disaster type.
For sure. And I mean, there's always disagreements between Canada and the US too, especially when it comes to that ductility factor, right? I think in the US for tilt-up construction, that ductility factor is, I think they can reduce it like a third more than we can. So their loads are inherently 30% lower than ours.
Right out the gate.
Right out of the gate. Yeah. And you get into that weird discrepancy where a building 50 clicks north of the border is designed for way more load than one in Washington. So, it's an interesting conversation.
Well, in my Tiger Lock world, I noticed that because I was on the energy modeling and the climate zones. And in the state of Colorado, there's two counties that are like beside each other and they have different classifications on what their energy modeling is. And like literally they're 5 minutes apart from each other. And I was like, how do you guys manage, designing here, designing there? Because like I want to say, correct me if I'm wrong, it's province. I mean, you did mention that up north it is a little bit higher of a seismic, but typically is it province by province where the differences come, or is it more regional based?
What's that, sir?
Kind of like frost cover. Like down here, you're 18 inches. Up in the Okanagan, you're 4 feet.
A little bit. The seismic load will vary depending on how close to a fault you are. Right? Because
so actual location to the fault.
Actual physical locations. So, I mean, you can go to NRC right now, which is I believe it's the National Research Council for Seismic Loading.
Are they the ones that determined there's an earthquake after the Seahawks big win?
Yeah. But what they do is based on the GPS coordinates of your site, they will find the 6 closest, I believe 6. It could be a different number, but they find the nearest stations that are monitoring seismic activity, and they will find what you should design your site to based on the monitoring stations all around.
So that's where you said the new tear that they found could affect calculations in that area.
We're primarily dominated by that Juan de Fuca fault right off our coast. And that fault goes all the way down to California. Right. So everybody on the West Coast is affected by that fault line. And that's why everybody on this coast is dealing with really high seismic loading.
Yeah. Yeah, all the way through, because California deals with it as well, don't they?
The whole Ring of Fire, no?
Yeah. We have friends down there that build buildings in California. And it's a tough go. Same as us. On the design side, like I guess working with architects and stuff like that, like how frequently, or maybe give us a story of sometimes that, somebody sends through some, maybe some backgrounds of a project that's, just getting started into design, and then you're looking at it going, no, I can't make this work.
Don't pick ones we gave you.
Yeah. Yeah, no, that's fair. I mean, it happens all the time. And the hard part is, because our codes change so dramatically on the seismic side every 4 to 5 years, things that worked 10 years ago don't work anymore today.
Yeah.
Or they don't work at the same budget they used to. That happens a lot. And even a year apart, if the code just changed, we can have a 10, 15% jump in seismic load. And all of a sudden, things that used to work didn't. But it's always that give and take.
But even just from, I guess, like on my end, from like a design standpoint. So like architects send through some backgrounds, and it's, super long and skinny and lots of windows in it and 70-foot tall panels. And you're like, no, like, how does that process go? Like, do you basically just go back and forth with the architect on what you're thinking or what can be allowed, and then they kind of change them? Because we see it. I see it all the time with, like large window openings, or they want lots of glazing on it. And you're like, okay, well, let's go spandrel in a bunch of these locations because I need to carry the structural layer of the panel through and stuff like that, right? So does that kind of back and forth? How does that go?
Yeah. So, the first thing that'll happen is we'll get an architectural set of drawings, and the first thing we'll look at, especially on a tilt-up building, is how much leg of panel do we need to get these panels to even work. So we'll go through and identify that and go back to the architect and say, we need at least this much to support both your roof load and the seismic loads on this building. And we go from there. When it comes to those intricate, fancy details, a lot of times we won't know until we spend a day looking at it. Yeah. And then from there, we can start pushing and pulling to make things work. But the first couple weeks of a project, or the first week of a project, is just that identifying all the problems. And the more experience your architect has with a certain construction method, the better off that first set of drawings that we're getting
for sure
is, and it makes things go a lot smoother. But
I was on a project one time, and there was the architect showed up for a field review, and we were talking about the structural engineer for some reason, and he says, it's that guy. And then the structural engineer came like a couple of days later, and he's like, yeah, that architect guy. And basically they just like duked it out for like a couple months on these brace bays that weren't supposed. Our owner didn't want them, architect didn't want them, and the structural engineer's like, no, you need them. And anyways, ended up with like a 200 connection and a massive wide flange beam. But it's just interesting because you got the dreamers, and then the actual put it together, kind of make it stand up.
You can make a lot of things happen for the right dollar figure.
Yeah.
But most owners don't want to spend elaborate dollars on structure.
Yeah.
Right?
Yeah.
Unless they want that fancy feature or whatever. But on the bread and butter, on the 90% of the building, you just want to be efficient.
Yeah. You talked about your field level experience back in the day. I don't think picking up Ross and picking up chickens is what I was getting at, but more to do with the structural steel stuff. How much of that do you feel kind of puts you maybe a little bit in front of others potentially, or gives you a really good kind of transparent view into how things actually have to go together, and how much of that goes into your design?
Right off the bat, I'll say a lot. What it allowed me to do is picture being the person putting a detail together.
Yeah.
Right? I can picture myself trying to reach in between the web and of a beam and a tilt panel to go get a weld, and physically knowing that my arm's not that long, and even if it is, I can't get my head in there to see it.
Yeah.
Right? Or being able to bolt things up, or being able to picture yourself doing that and knowing the pain and suffering that you're going to be putting these people through. for a bad detail is I mean, you can't teach it, right?
Yeah.
So that's been extremely helpful. Or even on the flip side, spending that extra 5 minutes or 10 minutes detailing a structural detail and knowing the amount of time that'll be saved on site is extremely valuable as well. Because there's nothing like going to a detail and understanding 90%, and that last 10% is when you guys start picking up the phone call, or you don't and you do it wrong.
Yeah.
Or you pick up the phone and you're calling everybody, you can't get a clear answer to the last 10% of that detail.
No, for sure.
It's been extremely helpful.
Yeah.
Extremely helpful.
That's cool.
Yeah, I mean, I was blown away at the TCA convention when we did the mock-up medley, the tilt-up panel we've talked about before.
Yeah.
And, guys are like, hey, that Dylan guy, he's great on the telehandler. And I was like, yeah, and he also was the engineer that put this whole thing together. And they're like, well, what does he actually do? And I was like, he just does it all. And then the next thing you know, you're out of the telehandler with the wrench, putting it all together. So, yeah, no, I'm impressed with that. And I think people see that on the site when you're out there, like you can have that appreciation.
It definitely helps to be able to relate.
Yeah.
Like I've been in the pouring rain, sitting on steel, trying to strike an arc and strike an arc through myself, right? I've been there. I've done at least a bit of everything. I haven't done it all, but I've done enough to appreciate what it takes to put out a set of drawings that both works and helps get it in a solution that works.
Yeah. For sure. And then being able to talk through it too. So like coming down to site and somebody still has an issue or this doesn't really seem to be working, you're able to just kind of, hey, let's do this. Yeah. This is okay. We're going to hammer this out.
It also allows me to push a little harder. There's been a couple instances where I'll get a little snarky and said, "Oh, fine, I'll come out there and I'll try and do it myself."
Yes.
And part of me is serious when I'm having this conversation back and forth with a contractor and a contractor saying that it won't work.
Yeah,
I'll come out there and give it a shot.
Or they don't want to do it,
and at least I'll come back and I'll know not to do that again. Right?
Yeah.
But I'm a little stubborn that way. But it definitely helps to have done it before.
Yeah.
Man.
So you brought up the term rabbit hole earlier. And do you know that's a segment that we did?
Send him a bit of a
okay.
Send him a bit of a
like I'm looking over the corner there. Once again, we're on the radio here on our podcast. But over in the corner in that bag there are some things that you maybe were involved of creating. So would you say that's a hobby of yours, or is it not a hobby?
A hobby of mine is finding a problem and solving it. And if it's a problem that I've never solved before, it's even more intriguing. Right. So I think like what you were pointing to there was a bunch of 3D printed panels.
That's right. I was trying to find the segue into it. So at least people know what it is now. Yeah.
I really wanted a 3D printer.
Yeah.
And we struck a deal between the two of us to, if I were to 3D model and print off these panels, that you'd help me get the 3D printer. So it allowed me to learn how to model in a way that could be 3D printed. I learned a whole new piece of software. I modeled this whole building for you and printed it off.
So since the building was modeled, which by all means is amazing how you did that, that's an actual replica of a building that is in the Lower Mainland, not built by us, but you could see it. What is the coolest or most unique thing that you do want to share with us that you maybe have made on the 3D printer? Because I've gone down the rabbit hole. I don't have the 3D printer, but like...
just for the record, I was going to say my rabbit hole was 3D printing.
Well, hey, you stole mine last episode, so so we're even now.
Yeah. What is the coolest thing you 3D printed? Did you do the Mr. Scrub Daddy holder that like he's into the sink?
Okay, that's on my list. Not gonna lie.
Did you make two?
No. Yeah. The coolest thing that I've 3D printed recently is actually tilt-up related, and it's lifting and bracing mock-ups. Because when it comes to lifting and bracing, we make a lot of assumptions, right? When it gets to really complicated F panels or cantilevered panels, we don't know exactly how they're going to lift. There's calculations and assumptions that we make. We stay within those factors of safety. We know it's going to be safe.
Yeah.
But how it actually
sideways
comes up might hang sideways. So there's been a couple instances now where I'll 3D print the panel with the insert holes in it and get a bunch of thread and have my own. I've got my own little rigging set up with thread and 3D printed spreader bars.
8-point lift.
It's a lot of fun.
What's the jewelry way?
The best was when I went to go pick it up and it was all set up, and Dylan's like, "Oh no, my kids were playing with it like it was a construction site." I was like, "I don't see any kids here. I just see you playing with your little crane and putting it all together." So
where does the structural steel B train come in? Which door?
Yeah. And again, I mean, the 3D printer is another tool to let you physically hold or get your head around what a detail is going to look like.
Yeah.
And that's what I use it for all the time is, okay, what does this look like?
Yeah.
Right?
How's this going to go?
How's this going to go?
Without putting much thought into it, do you feel that buildings, like I know they are in theory building buildings with 3D printers, but do you think that that is the way of the future? Or it could be done?
Oh, that's a tough question. I think it's going to have its place.
Yeah.
Parts and pieces?
Parts and pieces. Right? I mean, it'd be nice to have something that would go around a slab and print all your formwork for your panels. I think down at the TCA this past year, we saw those robots that are printing the layout of the tilt-up panel on the slab. Like that's where I see it. I don't see it taking over because, I mean, look at tilt up and how cheap it is to pour the flat slab and lift it into place. Do you really want to set up a 3D printer that can print panels that are 40 feet tall?
Right.
Right. I don't think it's going to happen.
Or how long that take for it.
It's not going to make sense in a lot of places, but it will have its niche, I think.
I'm just thinking, I mean, I was down the rabbit hole the other day with just, I mean, I don't know what it was. Maybe it was the algorithm that day on the Instagram for me, but like,
been there.
All kinds of different 3D. This guy had
a little spout to put on the sink that makes a water fountain.
Yeah, there's that. There was like this guy had it was like a colander, and then it had a chute coming off where you put the water down. Yeah, and it spins. Circle and spins. I was like, man, that's cool.
Yeah. The best part is when you see it and then you run over the 3D, go over to the computer, download it and hit print, and then it'll be ready in like a couple hours.
We should probably go
invest in the proper resins or whatever it was.
That's cheap. That's the cheap part.
That's the cheap part. Oh, right on. Sweet. Jeff, did you ever down the rabbit hole though? No, you've just been grinding it.
Well, I mean, I had a basketball one, so someone asked me that, like, you go to a hockey game, puck goes in the crowd, you keep the puck. Hey, look at me, I got a puck. NBA basketball games, you are not allowed to keep the basketball.
Really?
You'll be kicked out of the arena and never asked back if you try to keep the basketball or if you put it on your shirt and run. So do you guys know why that might be the reason?
Is there something special to do with the ball?
I mean, I don't have all the details because I didn't bring my notes because I had my other rabbit hole. But
Tom Brady, the Deflategate or what?
Every team is responsible for supplying the balls for the home team has to supply the balls, but the visiting team has the option to pick which ball they use. So if you watch before the game, the refs are out there, they're usually holding a couple balls, captain of both teams goes up, and then they're bouncing the balls and they pick one. Those balls are specifically made for the NBA. They are pre-bounced a certain amount of times. They're held at a certain temperature, certain PSI.
Oh, wow.
There's so much effort and time put into getting those balls for the game.
Yeah.
And they're limited that they need to keep them
Interesting.
for the game.
Did you hear about the baseball situation too?
Where
they rub the baseballs?
Pre-rub them.
They pre-rub the baseballs in the mud. And then I heard the hockey puck one too. Where they freeze them?
Yeah,
they put them in like a cooler with ice and like freeze them up beforehand.
Yeah. But so just
that's crazy.
The cost and the effort behind putting the basketball. So if anyone wants to YouTube what goes into getting a basketball ready for the game, it's crazy. The little journey that basketball.
Do they still use TF1000s?
No, they're not the Wilson balls now. So.
Oh, are they really?
Spalding is no longer the official basketball of the.
Oh, really?
Yeah.
Oh, my goodness.
It's been a couple of years. There was a little big backlash on that with some of the players, but
awkward.
There was no choice. Sponsorship money.
Yeah, for sure. For sure.
Goes. I think they've gone over that now.
All right. Dylan, we do have another segment called Your Welcome to Construction Moment. So I always kind of say this is like, when was it like a slap in the face per se? Like, oh man, like this is construction. I heard the trying to strike an arc in the pouring rain is always mine's rain related as well.
I heard striking the arc off yourself. I picked up on that.
Yeah.
So.
Yeah, I mean, there's been a couple of those. There's been, in the pouring rain trying to weld, and there's a river running through, and your boss comes up and says, here's the torch, just blast oxygen on it as you try and weld. And that seemed like a terrible idea, but we tried it anyways. And
does that work?
No, it just blows the metal all over. Like, it was terrible.
Yeah.
Welding in the rain sucked.
Yeah.
I think at that point is when I moved on and went to sort of pre-eng, where I'd only be welding here and there. It was mostly steel erection. And then they send you to the middle of nowhere, and it's hitting degrees of minus 50 Celsius, and hydraulic fluid is freezing. You get stuck in the lift. You're breaking bolts. Like, that's when I started like looking at school. Like, I need to get out of here. And I haven't hit my breaking point with engineering yet, but those are definitely my two breaking points from getting out of the tilt-up welding world into pre-eng into engineering. So.
Yes. Yeah, the cold just has a whole nother. I mean, I did a stint in Fort Mac and I did a stint in Edmonton, and I'll never forget there was a padlock that just like shattered on us one time. Your Bic lighter trying to warm up the lock, get the ice out of the thing so you can stick the key in it. And
yeah, you know you're in trouble when you're only allowed to work for 15 minutes at a time.
Yes.
And then you've got to go into that warming room.
Yeah. Well, I remember we were lifting a building one time, and I was we hooked all the clutches up, and then I kind of took a step back, and he was cracking the panel, and I'm like, I didn't see anybody. I'm like, where's the brace guys? And I turn around, and everybody is at the exhaust pipe of the generator, just like trying to warm their hands up. This is awful.
Yeah. Well, this was all happening where I was the grunt doing on the pre-eng crew, right? So we had this massive project, and there was these crane tie-back plates. And I think they had 50 bolts on each side, 51-inch bolts on each side.
Yeah.
And they had failed to account for the fact that the building was going to be hot-dip galvanized. So every single hole was too small.
For sure.
So I had to ream out hundreds and hundreds of holes. And I believe I had a whole turnaround. So 21 days straight of reaming holes with an impact and a reamer. And after those 21 days, I couldn't feel my fingers. I couldn't feel my hands. That was it. Yeah. I broke. Yeah.
That would do it.
Yeah, that'll happen. Yeah. That will happen. And then I guess lastly to touch on, TCA stuff. So, I mean, you're involved heavily with the TCA. How'd you get involved in that?
I'm trying to think back how many years ago. It would have been like 6 years ago. I got an invite from the TCA for a young emerging in the tilt-up industry to go down for a conference in Vegas at the World of Concrete.
Yeah.
And we started a group called
I just call them the Young Bucks.
Yeah,
that's my term.
Yeah. No, what we call ourselves was
Tilt-Up Leaders of Tomorrow.
Tilt-Up Industry Leaders of Tomorrow.
Yeah.
And was one of the founding members of that, and I was in there for a long time. And then from there, I bridged into...
Bridge/aged out.
At a certain point, it got too much for me. I'd gotten to a sort of a breaking point where I took on too much.
Yeah.
There's a lot of stuff happening in my personal life and in my work life, and it got to a point where I had to step away from that. I still sit on the Canadian board for the TCA, and we relay information to the TCA and sort of allow them to help us out here and maintain that connection to the TCA. So
cool.
Very close relationship. And it's given me a lot of connections to certain technologies in tilt-up, and especially in the structurally composite panels and all of that emerging technology. It's been really helpful. And if you're in the tilt-up industry, I'd definitely reach out to these because they'll change the way that you do tilt.
Yeah. Like, I mean, I know on the contractor side, we deal with a lot of, other TCA members, some people down in Florida, Texas, the Midwest. Is that kind of the same on the engineer front? Like, do you guys kind of, shoot the shit and talk about, different things and give each other tips and tricks? Or
99% of what the TCA is, it's the opportunity to network and the opportunity to build that network of people that you can call.
Yeah.
Right? If I have a really difficult technical problem, I will try all of my local resources.
Yeah.
And then I'll start calling people and leveraging the relationships that I built through members of the TCA on the engineering side. I no longer sit on the board of Tilt-Up Industry Leaders of Tomorrow, but I still sit on all of their chat rooms. And if there's something technical that comes up, they reach out to me, I reach out to them, and we can solve those difficult problems. And sometimes we can't get to a solution, and it sort of gets elevated to the TCA, and they say, hey, we need to look at this, right? Yeah. And that's happening right now on a bunch of fronts.
Yeah. Yeah, like, I mean, the collaboration, and we talk about it in depth than before, but just, I mean, that collaboration piece is huge, and being able to, lean on other members of that network to help you out and assist and ask questions, I think is really cool.
Yeah, you learn who started Tilt-Up. You learn who can you call to answer a question about a textbook that you're reading.
Yeah.
And it comes up with this name or this certain equation, and you can go to the TCA and you can find that person, have a conversation with them. And that's really cool.
Yeah, no, for sure.
Anything exciting coming up this year for you guys that you're looking at?
And the most exciting thing right now is just starting up the new company.
This podcast.
And the podcast.
Yeah, you just did it.
Yeah, just doing it right now. Yeah, I mean, a lot of stuff changing.
Yeah.
Right.
Yeah.
I think Tilt-Up is going to have its comeback moment. I think over COVID and the lack of this commercial real estate drive and industrial drive, was put on pause, but I'm starting to get this feeling that it's coming back. I'm starting to see a couple more projects start to pop up, and I'm getting excited for sort of where the industry is going.
Yeah, cool.
That's good, because when the engineers and the architects are getting busy, that means we'll be busy down the road.
Yeah.
Whole cycle.
We need to get some of that data center work because we've got the power in the land. So
yeah. Let's just go build 1 million square feet,
right?
Tilt up data center in Saskatchewan somewhere.
Perfect.
Yeah, middle of nowhere. Call it a day. Awesome. Well, Dylan, absolute pleasure having you today.
Likewise.
I appreciate you coming in and telling your story. You're always an intriguing fellow to talk to, and I thoroughly enjoy it. I know Jeff does as well.
Absolutely.
For sure. So thank you again. Catch you when we see you next time, for sure.
Yeah, thanks for having me, guys.
Thanks, everybody, for listening. Another episode of the Construction Dirt. Really excited to catch up with you guys next time, and follow us on all social media platforms, the YouTube, the Instagram. I don't think we're on the TikTok yet, but get out there, Spotify, Apple Music, and listen and drop some comments if you want to. Thanks so much, guys. Take care.